Okay, so before I move on to the next method of solving, I wanted to talk about some special circumstances, the difference of squares and trinomial squares. So this one you probably remember from back when I have two perfect squares and their subtraction, gotta have that subtraction, then I can factor that will always break down to the sum and difference of their square roots. The square root of x squared is x, and the square root of 25 is 5. So it's going to factor down to x plus 5 and x minus 5 equals 0. And again, don't forget that last step. Minus the 5, add the 5, x equals negative 5, and x equals positive 5. Okay, and we're going to talk more about the difference of squares in the square root method. This x minus 4 and x plus 4 equals 0 because the square root of x squared is x and the square root of 16 is 4, and it is a minus. You've got to come up with this difference. This is not the difference of squares. Yes, I did have two perfect squares, but it's an addition. And again, we'll talk more about that when we talk about our square root method of solving the quadratic equations. So just remember, subtraction, two perfect squares, plus and minus of the roots every time. It's just a little bit of a shortcut. And your answers come up pretty quick. All right, a trinomial square is a little bit more, but once you teach yourself how to recognize them, then it really does, and I promise you it's going to come up over and over again throughout the entire course. It really does give you a shortcut. First of all, you're looking, is my first and last term perfect squares? They have to be perfect squares. All right, this center term has to be 2 times the product of the square roots. So my square root here is x, and my square root here is 3. So 2 times 3x equals 6x. 2 times the product of your square roots. X times 3 gives me 3x times 2 is 6x. So since I have that, I can factor that down. X and 3 squared equals 0. My sign from in here is going to come from B. If it's a minus, it's a minus. If it's a plus, it's a plus. So x minus 3 squared. And you can test that. What can I multiply? That will give me a positive 9. That if I add, I get a negative 3. Well, this is x minus 3 times x minus 3. But kind of nice to be able to go from here to here because you recognize that that's a perfect trinomial square. Okay, let's try it again. I have x squared. As a matter of fact, I'd suggest that you stop, pause your video, and go after this one yourself before I do. All right, x squared, perfect square. 16, perfect square, right? All right, my square roots are 4 and x. So 2 times 4x gives me 8x, and that is my center term, so I do have that trinomial square. So what is that going to factor down to every single time? My b is positive, so x plus 4 squared equals 0. Just a nice, quick, easy way of factoring, right? And then what about if a is greater than 1? Same thing. It don't matter. Perfect square, perfect square. Square root of 9x squared isn't just x, it's going to be 3x, right? Square root of 25 is going to be 5. So 3x times 5 gives me 15x. So if I double that up, if I multiply that by 2, I get that 30x, right? So since that's a 30x, that meets my criteria. I have a trinomial square. So again, take those roots. B is negative, so my sign inside the parentheses is going to be a negative. And 3x minus 5 quantity squared equals 0. Okay? Try this one on your own. Pause the video and see what you can do with this one. Perfect square. 4 is a perfect square. X squared is a perfect square. 25, perfect square. Square roots, 2x. Square root is 5. So that gives me a 10x. If I multiply that by 2, then I've got 20x. So I have a trinomial square. So my roots are 2x, b is negative, minus 5 squared equals 0. Trinomial square and difference of squares, they are two shortcuts, things that make solving the quadratic equation and solving other equations later down the road a little bit easier. All right, we're going to close this one.